Hello students, in today's lesson we are going to learn about the mole concept. Thank you. Now at the end of the lesson, the students should be able to do the following. Define mole concept, state the role of mole concept in quantitative chemistry, show the relationship between mole and other parameters, describe the concept of stoichiometry, and how to balance simple chemical equation. Learn the 5-step process for using mathematical formula in chemical calculation, and then carry out quite a number of chemical calculation involving mole concept. Now, the mole concept. I will start by asking this question. How many eggs are there in a dozen? Can I get an answer? A pair of shoe means what? A gross is equal to what? And how many items are in a score? Now, some of the suggested answers I expect to get from you include a dozen means 12. For example, now, how many eggs are in a dozen? One in a dozen, there are 12 eggs. And a pair has a pair of shoe means 2 shoes. A gross means 144 items, and a score means 20 items. Now, a mole is a convenient unit of quantifying elementary particles. Now, when talking about elementary particles, we're talking about things like atom, molecules, formula unit, ions, electron, proton, neutron, and so on and so forth. So a mole is the amount of substance which contain as many elementary entities as they are in 12 gram or of carbon 12. Now, carbon 12 is an isotope of carbon that is used as a standard in relation to other elements. So a mole now is the amount of substance which contain as many elementary entities as they are in an atom, or in 12 gram of what, of this carbon 12. Now a mole also can be defined as exactly 6.02 times 10 raised to the power 23 elementary entities. So a mole of an atom, for instance, can be 6.02 times 10 raised to the power 23 atoms. If it's an ion, a mole of an ion can also be defined as exactly 6.02 times 10 raised to the power 23 elementary entities of what, of that ion. Now, a mole is therefore a standard unit in chemistry for measuring quantities of very small entities such as atom, molecules, ion, and electron. Now, the mole concept, that 1 mole, now according to the mole concept, now the mole concept says that 1 mole of any substance contains the same amount of particle, be they ion, atoms, and molecule. Now the mole also play a central role in quantitative chemistry. How does it do that? Because it shows a lot of relationship with many parameters in chemistry. For example, there's a relationship between mass and mole. There's a relationship between volume and mole. There's a relationship between molar mass and mole. There's a relationship between molar concentration and mole. Now let's take a look at some of this relationship. Number 1, mass mole relationship. Now there's this formula that I expect you as a chemist to know, which is N equals to M over M. Now, the small n there is the number of mole, the small m is mass of a substance, and then the capital M is molar mass. So this is a very important formula in chemistry that you need to know. Now, number 2, another relationship between mole and other parameter is the molar solution. Now we can see that there is a relationship between mole and concentration in mole per dm cube, as well as volume. For instance, N is equals to CV, where C stands for concentration in mole per dm cube, while volume of solution in dm cube. So by the time we want to go into maybe calculation using this, we must ensure that if here, since concentration is in mole per dm cube, your volume will also be in dm cube. Now if it is in centimeter cube, you have to convert it to dm cube before you can use it. The third relationship between mole and other parameter is the molar volume and is between molar volume and gases. And for instance, for gases as STP, that is, STP means standard temperature and pressure. That is when one temperature is at 0 degrees Celsius and at 1 atmosphere. And 1 atmosphere also has another unit which is 760 millimeter mercury, or 1.01 times 10 to the power 5 Newton per meter square. So that is the standard pressure, and then this also our standard temperature. Now 1 mole of any gas occupy 22 dm cube. So 1 mole of oxygen occupy, for example, 22 dm cube of what? Of oxygen. Of oxygen. Now, and then you can also use it. You can use this formula, that is N equals to V. The V should be in dm cube all over 22.4 dm cube. And then number 4, the fourth important formula that we also need to understand is the mole and ideal gas relationship, where we have PV equals to nRT. The fifth relationship is the relationship between mole and elementary particles. Okay, where we have N equals to number of particles over 6.02 times 10 to the power 23 particles per mole. Now, this 6.02 times 10 to the power 23 is also known as the Avogadro's number. Now, but before proceeding into mole concept calculation, it is important to have an idea of what the concept of stoichiometry is and how to balance simple chemical reaction. Now, what is stoichiometry? Stoichiometry is simply an important concept. It's an important concept in chemistry that help us to use balanced chemical reaction to calculate amount of reactants and products. In other words, it refers to the numerical relationship between quantities such as mass, volume, molecules of reactants and product before, during, and following a chemical reaction. So when we're talking about stoichiometry, we're looking about relationship between parameters, things like mass, volume, mole, between of reactants and product before, during, and following chemical reaction. Now, simply put, to balance chemical equation, there must be number of atoms on the left. There must be same number of atoms on the left and also at the right side of the chemical reaction. So that is just the simple way to know how to balance the equation, is that when you are balancing your equation, you ensure that the number of atoms of a particular element on the product side should be the same with the number also the number of atoms of a particular element in the reactant side. Now, in order to carry out chemical calculations involving use of mathematical formula, now there are these 5-step process that should be taken into consideration. So now let's look at the things that we need to do. Now these are 5. Number 1, list the constants. Now if you want to do any chemical calculation that involve use of a particular mathematical formula, you list the constants that are given and then the unknown variables. So you list what they're given. For example, if the volume is given, you write the volume. If the mass is given, you write the mass. You write you write it. If, for example, if let's say a pressure is constant, let's say at 760 millimeter mercury, or we have let's say we have H, which is Planck constant, is constant. So you write all your constants, then all that were given. Let's say you are given the volume, you also write them out. Then those that are unknown, then you also write it out. That means that is what you are going to look for in that particular situation. Then the step 2, you provide a mathematical formula which connects the variables and the constants. Number 3, you do the correct substitution, that making the unknown variable the source of the formula. So whatever you want to calculate, if for instance, let's say we are considering energy equals to Planck constant times frequency. So if it is frequency you want to calculate, if it is frequency that is your unknown, then you have to make frequency the subject of the formula. Then number 4, you evaluate. By the time you when you make it from some formula, and then you input those variables that are given and those ones that are not given, then you get your answer. Then make sure your answer, you evaluate them to 3 significant figure, and then finally insert the correct unit when necessary. Activity 1. So I would like you to carry out this activity. Find the molar mass of each of the following: C6H12O6, HCl, Na2SO4. So we have glucose there, we have hydrochloric acid, and then we have sodium sulfate. So I would like you to find their molar mass. Then secondly, you have to also calculate the atomic mass of a naturally occurring magnesium if the distribution of isotope is 78.19. That is for 24 for magnesium with mass number of 24, and then for the other isotopes 25 and 26. Then you have their percentage, that is their occurrence, the percentage, their what's called the percentage abundances, those numbers that are before them, like 11.62 and so on and so on. So by the time you do, then you check it with the answers that are provided there. Now, molar mass. Now, molar mass of a substance can be defined as its relative molecular mass expressed in gram. Like we can see the molar mass of H2SO4 there, that's sulfuric acid. You see we have one hydrogen, we have two hydrogen, and hydrogen, the atomic number is what? Is 1. The atomic mass is 1. So by the time you multiply it by these 2, so that's where we have this 1 times 2, then plus, then we have S, which is sulfur, and sulfur is 32. Then we have oxygen, we have 16 oxygen, so multiply by 4. So by the time you multiply everything out, you are going to get what? 98 gram per mole. Like we have mentioned earlier, that molar mass of a substance is what? Is just the relative molecular mass, or the molecular expressed in gram. Then relative molecular mass of isotopes and percentage abundance, like the two activities that were given, are under this. So that's why I want us to go through it, so I'll be able to do that activity without stress. Now, relative atomic mass, which we are going to be designated by what? RAM of an element, is the average mass of all the isotopes of that element. Is the average mass of all the isotopes of what? Of that element. Now, and it is given by RMA equals to summation of what? Of Mi, that is mass of the isotopes, multiplied by what? By abundance of the isotopes. For instance, let's take this example. Calculate the relative atomic mass of chlorine if it occur in two isotopic form, that is chlorine 35 and chlorine 37. You can see that they have the same atomic number but different mass number as a result of their what? As a result of a difference in their what? In the neutron. So with abundance, chlorine 35 is 75% abundant, and then chlorine 37 is 25% abundant. Now let's solve it. So we have relative atomic mass, which is equals to what? Our mass of the isotope multiplied by the abundance of the what? Of the isotope. So you can see for chlorine 35, the abundance is what? 75. So we're going to multiply 35 by what? 75%, plus, then for chlorine 37, we have chlorine 37, and it occur the percentage abundance is what? 25%. That is why we also have this what? 25%. So when you multiply 35 by 75, you get 2,625 divided by what? By 100. Then you have this plus. Then 37 multiplied by 25, you also get what? 925 divided by what? 100. So at the end of the day, when you multiply this, we have 100. You move it 1 and 2, then we are going to have 26.25, and plus, by the time you divide 925 by 100, we are going to have what? 9.25. So the relative molecular mass of chlorine by this calculation is equals to what? 35.5. Is that clear? So, and you can also see that isotopes explain why the relative atomic mass of elements is not always a whole number. For example, if you look at that of chlorine, it's 35.5. If you look at that of oxygen, it's 16.2. Now, the mole concept calculation proper. Now, the first question we have here is calculate the number of mole present in 5.3 gram of sodium carbonate, sodium trioxocarbonate 4, and we are given sodium to be 23, carbon to be 12, and oxygen to be 16. Then you write your solution, and then molar mass M. Now the molar mass, sodium is 23, so multiply by 2, which gives us a 46. Then we have carbon, which is 12, and then we have oxygen. We have 3 oxygen, that is 16 times 3, since the relative atomic mass of oxygen is 16. So by the time you multiply, you are going to get 106 gram per mole. So molar mass is always expressed in gram per mole. Now that's our molar mass. Then what is the number of mole? Now you recall we have a formula that says that number of mole is related to what? To mass over molar mass. That is N equals to M. That is mass of substance over molar mass of substance. Now we will give from the formula, you can see one of the given here, which is 5.3 gram. So by the time you divide by the molar mass, which we have just calculated, 106, we're going to get 0.05. And when you divide gram per mole, what you are going to get is, you can see we have a gram divided by gram per mole, gram over 1. Then you change this division to multiplication, and then as soon as you do that, you reciprocate. That is, the mole goes up and then the gram comes down. So you can see that is how we come to the realization that that N is is in mole. Then the second question is calculate the number of mole present in 2.25 times 10 to the power 21 atom. Now, how do we go about this? Now, the solution. Now, there are two ways of doing it. So the first way, or the first method of doing it, is just to say 1 mole of copper atom equals to 6.02 times 10 to the power 23 atoms. We have said it earlier that 1 mole of a substance contains 6.02 times 10 raised to power 23 of that particular elementary entities. And here we are dealing with atoms. So assuming it's electron here, we will say electron here, and assuming it is ion here, we'll say ion here. And then we are also given 4.25 times 10 to the power 21. So we want to know how many moles, if in 1 mole we have 6.02 times 10 to the power 23 atoms, then how many moles would now be in 4.25 times 10 to the power 21? So all you need to do is to say, okay, let's say x mole equals to 4.25. We have this as our standard already. Then you do cross multiplication. So we're going to multiply this by this, and then multiply this by this. Okay, when you multiply them, you get something like this. Then the next thing is to do is to divide both sides. Okay, divide both sides by by 6.02 times 10 to the power 23 atoms, because you want to get rid of this, since you want to calculate for x. Is that clear? So by the time you divide both sides by 6.02 times 10 to the power 23, then what do you get? So we're going to get 4.25 times 10 to the power 21 times 1 mole. Atoms will cancel atom. So by the time you divide 4.25 by 6.02, you get 0.76 times. Then we have 10 and 10 here. 10 raised to the power 21 and 10 raised to the power 23. Now, according to the law of indices, you are going to take one of these 10. Is that taken? Then you bring 20. Then you have your 21 here. Then because of this division, law of indices say for division we subtract. So we're going to write 21 minus. Now this minus is is for this division. Then you have your 23. Okay. Then 0.706 times 10 to the power 21 minus 23. Then here, now because we want the number to be in a standard form, so we also like to move this point from here to the after 7. Okay, so now 7.06 times, then 21 minus 23 is minus 2. is minus 2. Now we also have this 10 minus 1. How do we come about it? Is because here originally it was 0.706. So what you need to do is that by the time you move it by 1, that means we now have 10 minus 1. If you move it 2 times, it will be minus 2, and so on and so forth. Okay, but we just need to just move 1 so that we just have 7.06, so it will be in a standard form. Then we have 10 minus 1 times 10 minus 2. So we have minus 1 here. And then these times we have plus according to law of indices. Then we have minus 2. This is minus 2. So we now have 7.0 times 10 minus 1 minus 2. So the answer is what? 7.06 times 10 minus 23 minus 3 mole. Alternatively, you can also use formula. Use this formula, which is number of mole equals to number of particles divided by 6.02 times 10 to the power 23 particles. Now we have our n, which is unknown. We have our number of particles, which is 4.25 times 10 to the power 21 atom. That is what was given. Then if you input it in the formula, we have n equals to 4.25 times 10 to the power 21 divided by 6.02 times 10 to the power 23. Because the atom will cancel atom, we have per mole. But by the time you divide 1, let's say 1 divided by 1 over mole, you get what? Mole. So by the time you divide this by this, you're going to get 7.06, and if you divide this by this, you're going to get 10 raised to the power 3. Then the next example is find the number of moles in 200 centimeter cube of 0.25 mole per dm cube. So like we've said earlier, from the 5-step process of using mathematical formula to do what? To calculate, to do some chemical calculations. What do? We say we have volume, which is 200 centimeter cube. It was given unto us. We also have C, which is our what? Concentration, which is 0.025 mole per dm cube. Now look at something. The volume was given in centimeter cube and the concentration was given in dm cube. That means they both, and I've said it earlier, that they must have the same unit. And how can they have the same unit? By changing or converting the centimeter cube to what? To dm cube. And the simplest way to convert dm cube to cm cube to centimeter cube is just to divide by 1000. Because in 1 dm cube we have 1000 centimeter cube. So by the time you divide 200 centimeter cube by 1000, you get 0.2 dm cube. So I've converted it to what? To dm cube. So you can now recall the formula or apply the formula by saying n equals to cv. Our C is what? Concentration, which is 0.025 mole per dm cube multiplied by 0.2, and then n is also 0.025. dm cancel dm cube cancel dm cube, so we are left with mole. But when you multiply 0.25 by 0.2, you get 0.05 mole. Then the next one is what? To determine the number of 16 dm cube hydrogen gas at STP. The same procedure. You collect your data. Volume was given unto us, which is what? 16 dm cube, and then number of mole is what we are looking for. And we said when we recall this formula, n equals to v in dm cube divided by 22.4 dm cube. So by the time you divide 22 by 16 by 22.4 dm cube, then you get what? 0.7 mole. You can see the alternative method of solving it. Then the next one is how many moles of 250 centimeter cube of an ideal gas exerting a pressure of 720 millimeter mercury at 37 degrees Celsius. Now what do? You collect your what? Your data. Now how do we collect our data? The first data we're given here is what? Is the volume, which is 250 centimeter cube, and I said the first thing you need to do is what? Convert it to what? To dm cube by dividing it by what? By 1000, which now give us 0.25 dm cube. Then pressure was given to be what? 720 millimeter mercury. Is that clear? Now, but we need it in what? In atm, that is in atmosphere. And what you do, and one atm is equals to 760 millimeter mercury. So all you need to do is also to divide 720 by what? By 760. then it will give you 0.947 atm. Then we have our temperature, which is in centimeter, which is in is in degrees centigrade, but we want it in absolute temperature, which is in Kelvin. So we're going to convert it by adding what, 273, which now give us 310 Kelvin. Then we have our gas constant. We have our gas constant, which is 0.0821. Now look at it. Now this is one of the reasons why we did all the conversion we did earlier, because in the what we're given as our gas constant has atm, so our pressure will no longer work if it is will not be compatible if it is in millimeter mercury. So we have to convert this to atm. You can also see that our volume is in dm cube in the constant, in the gas constant. So that means if we have what we're given in centimeter cube had to be converted to dm cube. And then we have our temperature, the one that was given was in degree centigrade or celsius, it had to be converted to Kelvin. Then when you input it into this, then do the cancellation, dm cube cancel dm cube, atm cancel atm, and then Kelvin per Kelvin, this is per Kelvin, that is 1 over Kelvin, that is Kelvin cancel Kelvin. Then at the end of the day, we're going to have what, 9.3 times 10 raised to the power minus 3 mole. Now this is the next the second class activity. So you are given 4.80 gram of ammonium carbonate. Find the number of mole of the compound. 2, the number of carbonate ion. 3, number of moles of hydrogen atom. 4, number of mole of ammonium ion. And then 5, number of hydrogen atom. Now, and I've also provided the answers. Now, the answers are not meant for you to cheat, but is to enable you to solve and self-evaluate yourself by comparing what you got after solving the activity by the answers that are provided here. Thank you for listening. So in conclusion, we have defined the mole concept. We have studied the role of mole concept in quantitative chemistry. We have shown the relationship between mole with other parameters. We have described the concept of stoichiometry and how to balance simple chemical equation. We have learned about the 5-step process for using mathematical formula in chemical calculation. And lastly, we have carried out quite a number of calculations involving the mole concepts. Thank you. We have come to the end of today's class. In the next class, we will be learning another important concept in chemistry. Until then, I remain your facilitator, Sunday Ibrahim.